In this chapter, we'll start looking at working with 3D in Notch. The first thing we'll look at are the use of lights and setting up lights in 3D, and specifically for use with real-time rendering. We'll cover topics such as deferred rendering, environment mapping, fast reflection approximations, also known as screen space reflections, and other tools and techniques relevant when lighting up your 3D scene. Let's dig in. Hello and welcome to lighting chapter of this essential course. We're going to start up by making sure that all our resources are ready to go. I see that one file, the video file here, is with a broken path to its location. So I'm just going to go for Find Missing Resources and locate that in my Asset folder. So with this done, now I'm ready to kick off. This chapter has a defined starting point and a finished look. So this is what we're going for. We're going to use some lighting setups. We're going to use HDRI image to light up and reflect the scene. And then we're going to use a volumetric lighting to emulate a projector's throat. So let's get started. I'm going to open the first layer and I'm going to walk you through the nodes that we have here in the initial setup. So we have one camera that we're looking through now. I'm going to hit 5 just to pan out and look around. And I'm going to hit 0 to come back to the fixed camera. We have a couple of lights. Let's call them working lights. So it's ambient light and directional light. So it's super simple lighting, but it helps us to understand and see the scene better. We have 3 primitives, so shape 3D set to a sphere, and 2 imported 3D objects. Here in the very bottom, we have a floor setup. So let's get started. First node that I'm going to add to the scene is going to be a very regular light. Just like any other 3D node in Notch, light comes into the very center of the graph. So I'm just gonna push it a little bit up and backwards so it actually starts to light up the objects in the scene. Right, I'm gonna position it here a little bit to the side so it hits the sphere. I think at the given moment I don't really need ambient light or directional light anymore. I just want to see this specific light that I just built. Great. I am manipulating this light with the shortcuts E, R, T, Y, by the way. E is the position, R is the rotation, and T and Y is different scaling options. Cool, let's talk about the very light a little bit. We can change its transform, so positional and scale values. We can set the brightness and cone angle in this light, and various other properties that are handy in lighting. One thing that I would like to draw your attention to is casting shadows, so I'm going to enable that. Now notice that even if I enable the casting of shadows, it doesn't really work just yet, and there's a good reason for that. If we want to see shadows being casted, we have to come back to the root node and enable deferred rendering. So with the deferred rendering enabled, we definitely see shadows working. By default, deferred rendering is off. If you want to do a little bit more advanced 3D work, you should always turn it on. For the good measure, I'm going to turn on the high dynamic range as well. So now back to my light. I can actually reposition it and I can see how it affects the shadows. I can even tweak the softness of the shadows. I think I'm going to leave it somewhere there on 2. Great, so I'm going to push this light a little bit to the side. Perhaps I'm going to give it the color, maybe something like cyan. And I'm going to grab yet another one. I'm going to connect it to the root and I'm going to position it straight over this sphere right here. There we go. I'm going to enable casting shadows on this light as well. Let's give it a color. Perhaps the shadows could be a little bit smoother, a little bit softer. So I'm going to leave it at 1. Let's try out another type of light, area light. So I'm going to add area light to the scene. Again, it comes to the very center of the viewport. I'm going to connect it to the root. And now I see that this light is actually working. So area light is a quad. So basically we can position it a little bit to the side and treat it as a diffuser, just like in a regular photography studio. Now area light has several properties. Let me showcase those properties now. It can be double-sided, so it actually emits light from both sides. And you can have visible surface turned on and off. Right, I don't think I need to see the visible surface. I'm just going to put it here a little bit on the side and perhaps I'm going to make it a tiniest bit bigger. Yes, I'm quite happy with this setting right here. Perhaps I'm going to give it a color too, so maybe something yellow. Notice an interesting thing that is happening here on the floor now. all of a sudden we have something of a reflection of this light. So perhaps this should be the next topic on our list when we're talking about lights: reflections. Let's start with HDRI image-based reflections. For that, we will need environment map node. So I'm adding environment map. I'm going to connect it to the root. Now, environment map does not work on its own. It requires extra information. That extra information is environment image. In this case, we have one available for us. That's glass passage 2K HDR. I'm going to connect it to the third input, environment image. So with that done, I already see that there's something happening on my floor. So how do I make sure that this HDRI image is actually regarded by the spheres and by 3D models? Well, every single primitive 3D model has a material bracket in the very bottom of its properties. So we could one by one treat every single 3D model and 3D primitive, or we could use an external material node. We have a whole chapter dedicated just for materials, but I think it's worthy to mention materials here as well, because this is such a powerful and versatile tool. Now, instead of setting up materials for every single 3D model and 3D object here, we could set up all the properties that we want in this one and only material node and pipe it to all those shapes available for us here. As you may have already noticed, if we hover over the inputs, the one and only input available for us is actually material. Same thing for these 3D objects, although they have different naming conventions for these material inputs. So I'm going to distribute this material node to all of these 5 3D objects. So how do we make sure that environment map node actually works with these 3D objects? Well, in the material, we have an option called environment mapping. And as soon as we tick that on, I see that it's already kicking in. So if I zoom a little bit closer, I will see that there are some reflections happening. To further tweak the reflections, I have to scroll a little bit higher up in the material node. And there I see that I have properties for metallicness, roughness of metallicness, and general specularity. So in this case, I guess we can bump up specularity quite a lot. Now, one specific thing about metallicness, it should be always treated as an on-off function. In the real world, there is no such material as halfway metallic. It's either metallic or not. And obviously you can tweak the roughness to your liking. For anything in between, plastic or rubber, you probably would like to tweak your specularity and specularity intensity. We can even give different colors for specularity and the general color setting. I think I'm going to drop down the color value a little bit so that the reflections are a bit more visible. Great, so environment map now is definitely working with reflections. Can we make it work with the actual lighting? Well, yes we can. For that we need an extra node. That extra node is called Skylight. Skylight is probably the best and nicest lighting you can get in Notch, but it's a little bit intense and expensive computation for your GPU. So I'd always recommend to start up by dropping the num sample directions to a little bit more modest number, maybe something like 50. So I'm going to disable these 3 lights so you guys see exactly how the skylight looks. Right, so how do we connect skylight and environment map? Now, if I hover over the inputs in the skylight, I will see that the second one states environment map. So I'm going to connect my environment map to the second input of skylight. All of a sudden, they're working together. It's a little bit too bright, so I'm going to decrease the brightness. Now we have a unison of reflections and lighting. For the good measure, I'm going to turn on the omnidirectional setting as well. So how can we push this setting a little bit further? Well, let's talk about volumetric lighting. Let's choose one of the lights that could be treated as a volumetric lighting node. I think I'm going to go for the one here in the center. So I'm just going to push it aside so we have it more in focus. And I'm going to enable the scattering intensity. Great, with that done, now I'm going to move on and add an extra node called Volumetric Lighting. As soon as I'm going to add this node, you will see that the scattering becomes a little bit more exciting. All of a sudden we have a bit more disbursement and we can control the fogginess of the light. And if we start simulation, you can see that there's animation of that smoke. Now we are not restricted to just color when it comes to volumetric light. We can actually emulate something like a projector. We do have one video file available for us, so we can pipe it into the light's first input projection image. All of a sudden, our light is throwing out this video of clouds. Right, let's get back to the zero to the main rendering camera. I think in the volumetric lighting, I'm going to add more sample density so we see it a little bit more flush and smooth. Maybe something like 3. Great. So we are regarding the HDRI image for reflections and for lighting, but we don't actually see the HDRI image. If we want to see HDRI image, we would add yet one more node, Skybox. I'm going to position my Skybox somewhere here in the very top. And I'm going to connect it to the root. So Skybox works directly either with the video loader that contains the HDRI image or with the environment map. I'm going to set up the environment map. I think it's a little bit too bright, so I'm going to reduce the brightness. There we go. There are plenty of great places to obtain HDRI images as resource. One of my favorite ones is HDRI Heaven. The reason why I like this website lots is because not only it contains quality material, but it actually offers a variety of sizes from 1K to 20K. And it's absolutely free of charge. For the real-time motion graphics use, I would always recommend to go for 4K or 8K. You definitely don't need to go as far as 16 or 20. So there's one more extra little bit that I would like to add to this setting is depth of field. The third option available for me is post effect called depth of field. That's exactly what I want to use. Since it's going to be directly working with camera, I'm going to connect it straight to the camera. I could connect it to the root, but I think it makes more sense to connect it to the camera as these two nodes work hand in hand. So now in camera node, I can choose the focal plane distance, range, and blurriness to my liking. So all of the reflections in this setting is actually controlled by HDRI image. But what if we want to reflect models one from the other? Well, for that we have screen space reflection node. There we go. Now we can actually see the reflection of the 3D model on the floor. Let me give you a little sneak peek to ray tracing. If you want a better quality reflections, you can use RT mirror reflections. Now mind you, these two nodes should never be used together at once. So I'm going to disable the screen space reflection. And I'm going to connect RT mirror reflections. Now notice it is hashed out red. And that indicates that some extra steps are required to make this run. So I'm going to press on a root node and I'm going to make sure that the ray tracing is enabled. And as I enable ray tracing, I see that the reflections now are really sharp and they're much better quality. Obviously, they're a little bit more expensive on your GPU. Right, so let's recap the different lighting setups we used here. We used regular lights and we made sure to enable the shadow casting. Shadow casting only works if the deferred rendering is ticked on. It is ticked off by default to preserve your GPU computing power. We've tried out environment map, and environment map is working hand in hand with material, because in material we ticked on environment mapping. And then we worked a little bit with volumetric lighting. So one of the lights actually has scattering intensity enabled, and volumetric lighting gives us this simulation of projector's trough. Then we spoke a little bit about reflections from model to a model, and there's two options. It's either the screen space reflections or RT mirror reflections, depending on what GPU allowance or what GPU budget you have. So with that said, I look forward to see you in another chapter where we put all of this knowledge in practical terms. Welcome back to the course. In this workshop, we'll be rounding up all the knowledge we've gained in previous chapters. So just like in the previous workshop, we have a starting point. We will work on this setting a little bit more, and we will add some lighting. We'll add an image plane in the back of this setting, and we'll apply some post effects. So we're gonna merge 3D and 2D compositing. So let's get started. I'm gonna click on a third layer here, building start. I'm gonna walk you through the different nodes we have in the scene. So we have a camera that we're looking through. We have a couple of lights, the very same ones we discussed in a previous workshop, ambient and directional light. So these two lights helps us visualize the shading a little bit better. And here we have a 3D model. Big thumbs up and thank you for Igor for modeling it and for Christoph for actually making a concept art for it. With that said, I think we're ready to start. I think the first thing would be to disable the ambient light and directional light. So I'm hitting Control 1 and I'm gonna add a regular light to the scene. Connecting it to the root. Now, why did everything go black? Well, it did go black because we have a light in the scene. I'm hitting 5 now, but this light is in the very center of the graph and it's actually in the building. So if I just pan it out a little bit and up, you will see that now it's hitting the building. As soon as we add the first light to the graph, notch is referring to that specific light and it stops rendering the flat shading. Okay, cool. So I'm gonna position this light a little bit higher. Maybe I'm gonna rotate it a bit as well. Maybe somewhere here should be fine. Great, I'm gonna disable the grid. So I just pressed Alt-G. Now I do want this light to cast shadow. Oh, look at that, it's not working. Well, why is it not working? Again, deferred rendering is required for the shadows to be casted. So for the good measure, I'm gonna enable the high dynamic range as well. Cool, so with that done, now I see my shadows working and I can work a little bit more on the positioning maybe. Yeah, something like that. I might as well give it a color. Maybe cyan. Great, let's grab another light. Let's position it somewhere else. So this light came to the center of the graph as well. I think I want this light on the opposite side. Feel free to put the lights wherever you want. This is definitely not something you have to click and follow. I just want to make this building a little bit more dynamic, a little bit more interesting with several lights on it. Maybe this could be red. I think I'm gonna grab another type of light now. The area light. Again, I'm connecting it to the root and it came to the center of the graph. So yet again, I'm pushing it a little bit up. Maybe closer to myself so I actually see how it looks. And in this case, I want to make some changes. So I'm hitting R. I want to turn it a little bit or pitch it. And I want this to be bigger. Great. I don't want to see the surface. I'm going to tick off visible surface and I'm going to make it double-sided. I just want this light to intersect the building and let's say be red. Let's create some drama. There we go. I think maybe one more here for the top because it's a little bit boring there in the top. So I'm just copying now one that I already had and I'm gonna push it a little bit back and to the top. Maybe give it a cyan treatment or cyan color as well. Yeah, this starts to look a little bit more dynamic, a little bit more interesting. Okay, I think now it's time to address the background. As mentioned in the previous chapter, we do have several ways how to output image in Notch. I ever so briefly mentioned image plane. I think this is a great time to try it out. So I'm gonna drag it in from the node list. I'm gonna connect it to the root. Again, it came into the very center of the graph. That's why I don't see it. So I'm just gonna push it backwards. There it is. There's my white quad. A little bit up and I'm gonna make it bigger. So I'm hitting 0 again so I would look through the camera. Now I'm hitting E to make sure that I have positional values. Again, ERTY. Those 4 shortcuts are probably your best friends by now. And I think I'm ready to pipe in some kind of a video loop. So I'm gonna grab this dark sky loop. This is literally just clouds going back and forward or forward. And I'm gonna pipe it into the first input of the image plane. Okay, great. This is working. Now let's talk about specific property of image plane. Image plane by default is a quad. Our video is 16:9 format. So how do we match these numbers? Now we can fix that in 2 ways. We can manually expand the width, Or we can choose aspect-based scaling mode to look at scale X. And as it does, all of a sudden we have a correct width and correct height. But that's great. So with this being fixed already, I think I can make this image a little bit bigger, maybe even push it a little bit backwards. I just want this to fill the whole canvas. We have a little bit of an angle because the camera is positioned lower, like it's not looking at this building straight. I'm rather happy with this. Okay, so what's next? Well, I think it would be nice to match the color palette of this 3D model and this background, because they are really, really in a different realms now. I can do that with tint node. So I'm gonna grab tint and apply it on the video loader. Now with the tint selected, I have three options: color picker, Windows color picker, and the picker. So I'm gonna use that exactly. I'm just gonna choose some color from the actual setup that I have here. I think this works. Another thing that I would like to fix is the fact that we can see the borders here. Now, I don't necessarily like that. I would like this to fade to black. And we can do that with the alpha image, with the gradient. So just like we've spoken in the first chapter, we can use matte workflow here. So I'm going to go ahead and type in gradient, as we do have a generator for it. Great, now I have a gradient. I'm going to shift double click to expand it. By default is linear. I'm going to make sure to preview it in the viewport too. Instead of linear, I want this to be radial. That's great. And I want this to be in a width and height of our actual video setup. So 1920 and 1080 on width and height. Now I'm ready to pipe it into the second input. Great, it is working. I think I do want to shape it a little bit more. So I'm going to give it a little bit more of an inner range. And maybe I'll reposition it. Yeah, maybe a bit lower. And could it be wider? Yeah, why not? And I'm going to increase the outer range as well, actually, because that just makes it look much better. So maybe 1.2 and 0.8 here. So inner range 0.8, outer range 1.2. I think this works. All right, let's apply some post effects on the overall composition. I think I'm going to start with a vector blur. So I'm grabbing vector blur, I'm going to connect it to the root. The steps are a little bit, the number of steps is a little bit too high. So maybe something like 20 here. We can even change the orientation. So 120. How about reducing the dampening? Yeah, actually that helps. So maybe 0.6 here. Okay, great. This looks a little bit more uniform now. That's good. There are some post effects in a post effect list that require some extra information or require specific things to be turned on. Now, one of those would be 3D object outline. Now, if you don't have a 3D object, this post effect wouldn't do much. But as soon as you have a 3D object in the scene, you will see that it actually gives you a little outline. And that's great. So let's use it. Think in a 3D object outline. I'm going to make this outline red. And let's see if we can make it a little bit wider. Indeed, we can. That's good. But I think I'm going to reduce the normal amount. And I think I'm going to reduce the depth amount a little bit as well, just so it evens out with the rest of the setting a little bit more. Okay, cool. So what's next? Well, next there's a practical tip. For instance, if you're working with a very active post effect, something like a digital block glitch, just going to add it to the graph, connect it to the root, you will notice that this becomes very intrusive. And if you press 5 and you want to reposition some 3D models or make some alterations to the scene, this will cause you a headache relatively soon. So what's the best way to fix it? Well, we're not obliged to connect post effects just to the root node. We can definitely connect it to the video loaders, nulls, and composites, and to the camera. So I can grab all three of those post effects. I'm going to press Ctrl Shift to unhook them from the root, and I'm going to connect them all through camera. Now, when I hit 0, active rendering camera, I see all of those post effects available and applied, but if I'm in a orb view, none of them are there. And that actually helps me. I can actually work on the scene a little bit more, make alterations to my liking without those post effects interfering with my workflow. Right, I don't think having digital block glitch is a good idea, so I'm just gonna go ahead and delete it. Right, I think we're almost done. What I do want to try is a different color on a 3D object. Perhaps blue would tie this setting nicer. In fact, again, I can use the color picker and just choose the very blue that I want to apply. Yeah, maybe something like this. This is a little bit more subtle. Okay, I think we can round this up by adding some kind of a LUT. So I'm just gonna go to my assets, LUTs folder, and I'm gonna drag them all in. And I'm gonna pick and choose whichever the one would make this look even nicer. So I'm gonna connect it to the camera. And I'm just gonna cycle through and look for that one LUT that makes everything perfect. This is nice, but it's a little bit harsh. I think I'm gonna stay with the painterly. In fact, let's add a little bit of noise here. So we have a film grading post effect. I'm gonna apply exactly that. So I'm gonna connect it to the camera. I think I'm gonna reduce the chromatic amount because it's a little bit excessive. I'm gonna give some tone map gamma, so 2 there, and I'm gonna increase the noise amount. There we go. I think we're all done. Obviously, you can add more lights, more post effects, and different backgrounds. But I think I'm gonna go and prepare for the next chapter. So see you there.